The birthday paradox. There are a number of people in a room. How many people do you need in the room before there is at least a 50% chance of two people sharing the same birthday? On first thoughts, you might think, well, there are 365 days in a year, not including leap years. Surely we're going to need at least half of that for the number of people for there to be at least two people sharing a birthday. So maybe you need 183 people. Nope, it's lower than that. Maybe you need 100 people. No, still lower. What about 50? Still lower than that. The surprising answer is that to get at least a 50% chance of two people sharing a birthday, you only need 23 people in the room. The thing we've got to realise is we're not talking about two people sharing a particular date. So if you walked into a room and wanted to know the chance of somebody in the room sharing your birthday, you would need a lot more people. We're just talking about two people sharing a birthday. It could be any of the two people in the room, as long as there are two people. Let's do the maths on this. We've got two people in a room. Suppose we know the first person's birthday. We're going to start by working out the probability that the second person has a completely different birthday. Well, there are 364 days of the year that aren't the first person's birthday. So the probability that they've got different birthdays is 364 over 365, which is 99.73%. So the probability that they've got the same birthday is 100%. Take away this, 0.27%. So if there are two people in the room, there's a 0.27% chance that they share the same birthday. What about if there are three people in the room? Let's start with looking at the probability of them having different birthdays. So, first person has a birthday on a specific date. For it to be different, the second person would need a birthday on one of the 364 days that are left. And the third person would need a birthday on one of the 363 days that aren't the first two people's birthdays. So the probability that they've all got different birthdays is 364 over 365 times by 363 over 365, giving us 99.18%. So again, the probability that at least one of these pairs shares a birthday is 100, take away our previous answer, 0.82%. So our probability is still very low, as you would expect. What about if a fourth person joins the room? Going by similar logic, this is how we will work out the probability that they've all got different birthdays, 98.64%. So the probability that there's a shared birthday in there would be 1.36%. It's starting to get larger, but it's still a long way from 50%. So now we've got 10 people in the room. We're going to do the same thing. 364 over 365 times by 363 over 365, and so on, all the way down to 356 over 365, which is the probability that the 10th person has yet another different birthday to the previous 9, which gives us a probability of 88.31% that everybody has a different birthday. So the probability that there's at least a shared birthday in a group of 10 is 11.69%. Now, the easy way to think about this is if we create a quick formula. So the probability that in a room of n people there are n different birthdays is used by the following formula. This is based on the fractions we've been using so far. As you can see, we've got 365 over 365 times by 364 over 365, and so on and so on. By simplifying this, we can do 365 factorial over 365 to the power of n times by the factorial of 365 minus n, which becomes n factorial times by 365 choose n, all divided by 365 to the power of n. Now this is a formula for the probability of n different birthdays. So to find the probability of a shared birthday, we just take our previous answer away from 1. Using our formula, this gives us the following probabilities. By the time there are 20 people in the room, the probability that at least 2 people share a birthday is 41.1%. And we only need to get to 23 for that number to tick over 50. There's actually a slightly bigger than a half chance that if 23 people, there'll be a shared birthday. Now you can see that by the time we get to just 50 people in the room, there is a 97% chance already that at least 2 people share a birthday. By the time there are 70 people in the room, that's 99.9%. To put that into a practical sense, you could think of it as in if you've got 1,000 rooms, each room has got 70 people in, on average you would only expect one of those rooms to not contain shared birthdays. That is how likely that is. By the time you've got 75 people in the room, you've got a probability of 99.97%. And by the time you get to 100 people, the probability is 99.99997%. Almost certain that at least 2 people will share a birthday. But how many people do you need in the room before you can be certain that 2 people share a birthday? Well, of course, for that to happen, you need 365.